Hey everyone, I wanted to record a few videos on some of the homework problems that I think might be a little bit more challenging than the rest. So hopefully this video helps you. This is for, I believe, problem number 3 from the homework. So use differentiation to find a power series representation for, and we have quite a few. And these are essentially because you're going to use differentiation. So find a power series. This should be the derivative essentially of some power series. Then part B, notice that the power on the bottom is increasing. So this is likely the derivative of part A. And then this is essentially part B multiplied by x squared. So then the question is, well, which power series should we use here? And notice that for f of x equals 1 over 1 plus x, right, the derivative of this is minus 1 over 1 plus x squared. So then I know I'm going to use this power series, but what about the 2? So let's work on that. All right, so for part A, I know that I want to use the power series for 1 over 1 plus x, which remember, this is the alternating geometric. Which is really the power series, right? Minus 1 to the n, x to the n, from n equals 0 to infinity. So that's the power series that we want to use. But our function has a 2 in it. So let's look at what does it look like when I have just 1 over 2 plus x here. So we can factor out the 2 from the bottom. I'm going to try to match the color of what the book had. So if I then factor out the 2, what am I left with? Right, we'll be left with 1 plus x over 2. Right, if you multiply the 2 back in, then you get 2 plus x. All right, so this is my new f of x, and now I can say, well, then this is 1/2 times 1 over 1 plus x over 2. And now I can take the derivative of this. Why do I take the derivative? Well, I know that what we did up here, right? 1 over 1 plus x, its derivative is negative 1 over 1 plus x squared, which will give me that function in part A that I want the power series for. So when we take the derivative here, let's call this f, then f prime. What is f prime? Well, I have this 1/2 here. Let me write it with the negative exponent. So this is 1/2 times 1 plus x over 2. So we'll need some chain rule here to the minus 1. So this is what f equals. Therefore, our f prime is what? So let's take the derivative here. So it'll be negative 1/2, right? This 1/2. Bring the negative 1 down times the inside left alone. Subtract 1 from the exponent to the minus 2. But by chain rule, times the derivative of the inside. The derivative of the inside is 1/2 again. So f prime of x is, what is this then? Negative 1/4 times 1 over 1 plus x over 2 squared. Right, and remember, our 1 over 2 plus x became 1 over 2, 1 plus x over 2. I can see, right, can you see why this one is a little bit harder, right? So how is our function in part A? Is equal to 1 over 2 plus x quantity squared. So how is this equal to that? Is the question. So think about that. How can I see this function, our function from part A, in this derivative up here? Which this function, right, if you take out the 2 from here, notice that it will be 2, 1 plus x over 2 and then the whole thing square, right? Which is 1 over this 2 square is 4, and then 1 plus x over 2 square. Now, notice that the derivative of this function, right, is pretty much this r function in part A, except for our function is positive and this derivative here is negative. So that means that our function in part A is, right, 1 over 2 plus x squared. This is really equal to then to the derivative of our function up here, but I have, when I take the derivative, I gain that negative. So this is really the derivative of negative 1/2, and then my function 1 plus x over 2 to the minus 1. Let me write it the way it fits the power series. Right, so then, and again, this negative is because when I take the derivative of this function, I gain a negative, but my function part A does not have the negative. So that's just a constant, so we can take the negative out. So it's negative 1/2, the derivative really of our function. So I kind of did the work first, and now I'm trying to figure out how does this fit with the power series. So then this is the derivative of our power series, which is negative 1 to the n times x, right? And our power series, as we saw up here, where did I write the power series? Right here, it's negative 1 to the n, x to the n. So then this is going to be negative 1 to the n, x over 2 to the n, right? That is our power series. So when we take the derivative of this, right, I can say this is really the derivative of the function inside. So I'm going to have negative 1/2 summation of minus 1 to the n, and then take the derivative here. X is the variable, right? So then this is going to be x over n to the n minus 1. Well, bring the power down, so it'll be n times x over n to the n minus 1 times the derivative of the inside, which would be 1 over n. So my n's actually end up canceling off. So that means that our function from part A has the power series negative 1/2. Let's see, when we take the derivative, so notice that our first term when n is 0, right, this is a constant, so when you take the derivative, that's going to go away. So we're going to start really at n equals 1 then to infinity of minus 1 to the n plus 1, since we moved 1 over, right? And then x over, oh, it's not n there, it's 2. So those don't cancel, just kidding. To the n minus 1. So I'm still going to have my n in here. So that n, sorry, does not cancel. So I'm going to have my n over 2, right? This n times that 1/2 becomes n over 2. And so that's going to be our function, our power series. So how did I do it? Well, it was recognizing that derivative, right? And then trying to manipulate this 2 to make it look like my power series 1 over 1 plus x. So when you have a constant there, just factor that constant out and then see how does this function relate to my original. And in that case, it was the derivative. So for part B, notice that we have the same thing. So now this is going to be the derivative of part A. So really the second derivative of the original power series. So now from here, for part B, notice that 1 over 2 plus x cubed, right? This is the derivative of this one. Except that you're going to get, right, when you take the derivative here, what do you get? You're going to have 2 plus x to the minus 2 is the function. So when you take the derivative, you're going to have what? Minus 2, 2 plus x to the minus 3. So you end up gaining an extra constant in here. And so figure out how does that translate into then this. Right, so now I'm going to say, okay, so this is actually not quite true, right? Because the derivative of this has a minus 2, whereas this doesn't. So then this is going to be, my function in part B is minus 2 times, the derivative of minus 2 times this function. Now that I have from part A the power series for this function, I can do the same thing that I did up there, right? So then this will be minus 2 times the derivative of this power series, which I already have, which is negative 1/2 n equals 1 to infinity of negative 1 to the n plus 1 x over 2 to the n plus 1 times n over 2. And now take the derivative of this. So you can bring the negative 1/2 out, and so those will cancel. The negative 2 and the negative 1/2 become 1. So you're just doing n equals 1 to infinity of the derivative of the stuff in here. Now the variable is the x, right? So then we're going to take the derivative of this part. So it will be x over 2 to the n, and what do we do? Oh, did I write it wrong? Should be n minus 1, yeah. To the n minus 1 there, n minus 1 here. And then when you take the derivative, that will be n minus 2. And again, your first term, which is constant, is going to go away when you take the derivative. So you're going to have to move this to n equals 2. And that will make it, when you have n minus 2 there, that will give you the new constant term, and so on and so forth. And so you can continue this on your own. For part C, what is the function for part C? Part C was x squared over 2 plus x cubed. So find a power series for x squared over 2 plus x cubed. Well, from part B, you're already going to have the power series for 1 over 2 plus x cubed. So this is really x squared times 1 over 2 plus x cubed. And you should have the power series for this from part B. And so for this power series, right, then you just multiply x squared in there, which is going to mean that when you have x to the n minus 2, you're going to now have times x squared. When you multiply some bases, you add exponents, right? So when you have x over 2 n minus 2 times x squared, multiply the same bases, you're going to add exponents, so that's going to become x to the n. You're going to have to separate the 2 though, times 1 over 2 to the n minus 2, because only the x's go together. Okay, so I know I didn't complete part B and part C, but I'm hoping that just talking through what the process is will help you with your own homework. The numbers might be different, right? You might have a 4, a 6, or a 5 instead of the 2, but the process is the same. So it says, pay attention to the wording, right? Use differentiation to find power series for all of these. So that means that you're going to be taking derivatives of something. What is that something? You're going to start with a known power series, in our case 1 over 1 plus x. And the power series for that, it was the summation negative 1 to the n x to the n, the alternating geometric series. All right, email me if you have any questions.